Okay. So, so as they say, now for something completely different. So those were incredible talks. Really very interesting, John Hoy. I had a bunch of questions that I'm going to just email you, I think, or we can talk about after. Um, but what I want to present today is this is a project that is actually trying to think about scenarios of the future. So scenarios in the context of moisture recycling. And so it's in that spirit that I'm presenting this today. So the summary of the talk today is that this project was trying to explore how human modification of the atmospheric water cycle, what that might look like in the future. And so to do that, we introduced a new way of thinking about atmospheric water, so an economic goods framing, and I'll explain that. And then using a mix of quantitative, qualitative, and expert perspectives, we developed 10 story-based scenarios of the future of atmospheric moisture cycling. And then what we found from those scenarios was kind of rethinking how we have anticipatory capacity. How do we make sense of the future? How do we anticipate changes that might be coming towards us? And actually, this is exciting. This was published today. The work was finally published, and so this work is available, and I can make the link available after the talk. But it was that's a whole other talk. The long process of trying this work being published. But before I go forward, I want to just kind of give a few slides about what do I even mean when I talk about the future, and what are we going to be doing? What did we do in this work? And to orient us, I think it's helpful to have sort of like a shared vocabulary. So if we think about right now and all of the potential things that could happen forward from this moment, marching forward in time. The first one we can think about is sort of a basic extrapolation, sort of a business as usual, perpetual now, really easy to think about and represent, pretty boring, definitely wrong, but easy. Around that, we can think about something called probable. So maybe based on current trends, maybe statistically, we could think about it maybe 25th and 75th percentile, things that you would say that's likely to happen. Beyond that, we have things that are plausible. So based on current knowledge, this is something that could happen, maybe 5th and 95th percentile. So you can see that this cone of potential outcomes is getting wider. Outside of that, maybe we don't have statistics anymore to describe this future, but it's something that we could say it might happen. So this would be something that we call possible. And one step beyond that, we have preposterous. These are things that are impossible. These are things that won't ever happen. This is one of my favorite parts of the futures cone because this describes things that are really outside of the box. And honestly, especially when it comes to technology, if somebody says that, oh, that's impossible, that won't ever happen, it's good to pay attention because it'll probably happen, and it'll probably happen sooner than we all expect. But all of this has to do with likelihood. None of this says anything about preferability, if you want it to happen or you don't want it to happen. So in that case, we can put this other aspect of the futures cone there, some things that are preferable, where we ascribe a value judgment. And this can actually go all the way from the middle, the boring, the status quo, all the way out to the preposterous, depending on your perspective. Unlike these other topics, this is something that actually has to do with how you feel about something as opposed to, so you're a subjective assessment versus maybe kind of the objective probability. So I mentioned this cone because I'm going to be using some of these words in this talk, and I want you to have kind of an anchor for what I'm talking about when I say that. So in this work, we're not thinking about the middle part of the futures cone. We have excellent modeling tools. John Hui just talked about RCP 8.5, which is an emission scenario, a relatively extreme emission scenario, but it's an emission scenario that's used in climate models to understand the future. But that's still something that we can talk about in the language of probability. We're talking about things that are almost outside of that range, things that we have to use other tools to describe and interpret and understand. So radical futures. A radical future is a vision of the future that pushes the boundaries of social, environmental, and technological limits possibly exceeding them. This is Jim Dator. He's a professor emeritus and director of the Hawaii Research Center for Future Studies at UH Manoa. And he's famous in the futures community for these two laws of futures research. The first one is the future cannot be predicted because the future does not exist, which is sort of like a tautology, but it sort of gets at the idea that the future doesn't exist, okay? And because of that, when we sort of think about what's going to happen, we have to adjust our mindset, unlike when we're trying to understand the present. The future is an inherently different thing. I think sometimes we trick ourselves into thinking that it's a lot more like the present than it actually is. The second law is that the only useful idea about the future should at first appear to be ridiculous. That's not to say that we should all just throw our hands up and not do any modeling or not do any simulation. But in the case of trying to think about these far outside the edges of that futures cone, and we want to understand the present with better clarity, we need to really challenge our assumptions about what the future could look like. So why do we need these? Well, to that point, the future is going to be a strange place compared to today, especially anything after 2070. Technology change, social change, environmental change. This world is probably going to be unrecognizable to our parents, let alone our grandparents. And just to illustrate this, what is this? What are we looking at right now? Somebody unmute yourself and say, tell me what we're looking at in this image.
People working out.
People working out. But is it just people working out, or is this doing something else?
I don't know what's called in English, on a
Okay,
bicycle that doesn't move.
fair. It's an exercise bike. But it's actually an advertisement, right? Like this is an advertisement from the early 80s, late 70s for these exercise bikes, okay? This is a product. And so you can look at this, you can look at the people on these bikes, you can probably tell that's what they're doing, more or less. Let's contrast that with this. Ellipticals are hamster wheels for humans. Fitness is fun on Quest 2 Oculus from Facebook. Now, I won't drag this out. This has no context. If you didn't know this was a virtual reality headset, you would have no idea what this thing is. You wouldn't even know how big it is because there's no people there. There's no frame of reference. We don't have like a banana there to look at and say, oh, okay, it's about the size of a banana. So this is an utterly disorienting ad potentially. The point here is that the strangeness of this advertisement would be very disorienting to these people. If these people were transported to the present day, they would look at this and probably have no idea what they're looking at. The point is that the future will be as disorienting to us as this is to them. So in the context of these radical futures, what we're trying to get is a different kind of perspective. This is Kim Stanley Robinson, a well-known sci-fi author. He's written a lot of climate change, cli-fi. He says you can never properly predict the future as it really turns out. So you're doing something a little different. When you write science fiction, you're trying to take a different perspective on now. And that's what brings me to story-based scenarios. The idea of trying to explore the possible, the preposterous, and the preferable, those outer domains of the futures cone, and we can use stories to do that. Stories allow us to move beyond just kind of quantitative, objective model output and allow us to think about the future in a totally different way. And so what I'm going to go over is I'm going to quickly go over the economic goods framing that we introduced for atmospheric water, the methods that we used, which was a computational text analysis, an expert workshop, and some story-based futures. Really this talk, or really this project, was an effort to link my work on human interaction with the atmospheric water cycle. So this is what I did my PhD work on. I've continued to work in this space. And I've also done a lot of work thinking about story-based futures and published kind of a lot on that. And what I wanted to do is I really wanted to bring these two approaches together to think about futures for humanity's modification of the atmospheric water cycle. So to do that, the first step is I wanted to introduce a new way of thinking about the atmospheric water cycle. And in this way, I use something called an economic goods framing. And so we can think about this in the context of two different axes. So on the vertical axis, we have something that's called non-rival or rival. Essentially, does your use of something reduce the amount that's available for others. So let's take movie ticket. Like I want to go to the movie theater and I have a ticket to go to the movie theater. And so I go to the movie theater and I sit in a seat. And now that seat is no longer available to you to sit in. I've consumed that available resource, unless you sit on my lap, which I don't know you that well, so I'm not sure about that. And so that's one way you can consume the resource. The other one is excludable. So you can think about whether or not you can prohibit somebody, you can stop somebody from accessing a resource. So in this case, you could imagine like a ticket booth at the entry to a movie theater. And so somebody can say, you can go in, you can't go in. So you can consume a resource or you can exclude others. And with this, we get a 2-quadrant space of how resources around us are classified. So recently, atmospheric water was more or less a public good. It's this idea of saying that we're not going to consume it all and we're not going to exclude others from accessing it. So it's this public good. It lives in this upper left-hand quadrant. But in practice, it's maybe not quite that simple. So we know atmospheric moisture recycling is influenced by land use change, especially deforestation, especially in the tropics, can affect how much water is flowing elsewhere. So human activities can actually affect the amount. They can sort of consume that resource so that it's not available for others. And in the same way, even though it's probably not on purpose, large-scale land use change, maybe irrigating a desert, for example, can lead to changes in the circulation. So actually changes in who gets water can change as a result of human activities. So because of that, we have this changing potential dynamic of where water is maybe not a public good. Maybe it moves into these other domains. And then lastly, essentially the final quadrant is privatization, where you can control and exclude, or you can consume and exclude. And this is really, I thought that would be the most science fiction domain of this quadrant. But in reality, this is where cloud seeding, weather modification, precipitation enhancement lives. And this is a space that's increasingly sophisticated in how people are studying it, how it's being deployed, et cetera. And so it's these 4 quadrants that I wanted to explore with this economic goods framing. And so to do this, though, it's not as though, so this is a new way of classifying atmospheric water. But it's not new in the sense that people have done lots of analysis on almost different parts of this economic goods framing without calling it that. So what I wanted to do is I wanted to collect literature that people have studied this topic and maybe have inadvertently been studying it and could be classified in one of these quadrants. So to do that, I use something called a computational text analysis, which is a way of taking a whole lot of text and then using a computer to interpret that text. I should say that this is all pre-Chat GPT or pre kind of this like wave of AI-based tools for emergent generative text. This is all just based on kind of some off-the-shelf and customized Python code. And so to do this, what I did is I came up with a structured query, which is essentially just a systematic set of keywords that are used to collect a bunch of literature. I used Web of Science, and I collected just over 2,200 abstracts, loosely on this topic of different ways that anthropogenic or human modification of the atmospheric water cycle. And then I performed this sort of text analysis where I convert all of these abstracts to machine-readable text. I use the software to interpret the text and find how different words and ideas cluster together. Essentially, the software identifies, if you've ever done like k-means clustering, it might be analogous to that. That's a way of thinking about it. But clustering ideas in text as opposed to maybe numeric output. And so then I use something called coherence, which is a approach for identifying how robust your clusters are. And I produced a set of clustered text using this. And that's just sort of an illustration of what I just said. And this is an example, a visualization of the type of output that you can get. So on the left-hand side, what we have is we have this thing called an intertopic distance map. You can see PC1, PC2. This one way you can understand this is how related are these different clusters of text that appeared across this 2,200 member corpus. And we can see that some clusters or some groups of text are kind of tightly clustered or they're associated with one another. And then some are more spread out in this space. And so this is a visualization of the output from this text analysis. And then as an example, this is for topic number 9. we can see that these are the words in this right-hand bar graph going downward that correspond to this topic. And so from this, what we did is summarize the words into a kind of a coherent theme or idea that really describes this. And in this case, it's these words and these ideas associated together give this idea of Amazonian deforestation connected to evaporation and basin surface water supply. That's sort of distilled from this clustering of words. And so we did this, or I should say, I did this where I took the different clusters here. I distilled it down to these ideas, and that's what we see right here. There were a total of 18 clusters. 13 through 18 were fractional and kind of almost like nonsense clusters. So they made sense from the algorithmic sense, but they didn't make human interpretable sense. So I set those to the side. And there were also two other clusters that ended up being mostly about, say, carbon sequestration as opposed to atmospheric moisture recycling. So I set the carbon-based clusters to the side. So we wound up with 10 clusters, and then I classified them based on my interpretation of them into this economic goods framing. This is, I want to be clear, this is a point where I made the subjective choice of where they could exist here. And if someone else were to do this, they might classify them in a different way. Okay, so this was sort of the end point of the text analysis and the economic goods framing. Then what I wanted to do is I wanted to say, what if instead of me coming up with these story-based scenarios, I've done this a bunch, I have some experience, but what if somebody else did it? What if I was able to take global water experts and train them how to do this futuring, how to think and develop these story-based futures, and then have them develop these story-based futures about this kind of future of the atmospheric water cycle and how humans interact with it. So I recruited this group of people, and this was all during the pandemic, so it was all virtual. And I recruited this group of people where we participated, and so I trained them over the course of 2 days to do this story-based scenario development. And what I did is I assigned each person a different one of those clusters of words where they had the words and then where it lives in the economic goods framing. And then that was sort of their input. And then they got to do the scenario development on their own. And so what does the scenario development actually consist of? It's a combination of things. So there's things called world building, where you're essentially designing and imagining a future world. And it's not just kind of whatever you want. It's a structured approach, systematic imagination, if you want. And so these are the 4 of the steps that are involved in that process. There's not really enough time to go into each one, but I'm happy to answer your questions about them later on. And then the second part, so that was the first workshop, and then a subset of the expert participants joined for the second workshop, where it was really about creative writing. How do you tell a story in this world? And so from that, of the original 10, 5 of the participants went on to develop their own story-based futures, and then I took what the experts developed, and then I developed kind of the other 5 myself. And this is a summary table, which I don't expect you to read. But on the left-hand column, it's the titles of these different scenarios. The middle column is the economic goods quadrant that story is about. And then the right-hand column is a text-based summary of the world. So what was the world that was imagined for this particular combination of ideas and economic goods framing? And then what was the story that was told? What I'll do is I'm going to zoom in on one of these just to give you a sense of what I'm actually talking about. And this was a story called tea trading. So this is a story about the world is about where weather modification, precipitation enhancement, deliberate manipulation of the atmospheric water cycle has been banned. Essentially, it's been prohibited globally. And so, but a consequence of that is that people still really they would like to control water, but they can't do it deliberately with, say, cloud seeding. So what happens is something else happens where people start conserving forests in a totally different way to maximize transpiration flows. And in this future, transpiration actually becomes a commodity where you can trade it like an options or a futures contract, where you can actually trade transpiration futures so that you can maximize your potential atmospheric water flow. So that was the world. And that was, you might say that sounds totally strange. And that was the point. It's supposed to be a strange future. And then the story is about somebody who actually works for one of these transpiration futures companies. And it follows her as she goes around, and in this case, the Amazon, exploring her company's land holdings to understand better about the future of transpiration. But it's actually as much about her. The story is really about her coming back home. So she actually, even though she works for this big global company, the story is that she's actually having to deal with her local community, the place where she grew up. And you might say, like, well, what's the point? Isn't this supposed to be like telling us something useful about the future so that we understand the present better? That's true. But the point is that stories function entirely differently than, say, an XY graph or a map of the world. Stories access a different part of our brains, and so we engage with the content in a totally different way than we would, say, with a graph. So it allows us to think with a different mindset about the future. So that was one example. We did this for all 10 stories where we developed these story-based scenarios. You might say, where did you get this artwork? And we worked with an artist named Fabio Comin who developed artwork for each of the stories. So he developed a piece of concept art that accompanies each story as sort of a visual hook as a way to connect with either an audience or as a way to communicate what a story is actually, what the story is about. So again, you might ask, why would we do this? And one part is to think about, how do we change our anticipatory capacity? How do we develop new anticipatory capacity for the future? That is to say, how do we understand what might happen in the future? So the first one, how do we anticipate changes in regulatory regimes that will be oriented toward atmospheric water modification? How do we anticipate substantial improvements in the diagnostic and monitoring capability of atmospheric moisture, precipitation, and cloud microphysics? How do we anticipate overlapping crises that relate to atmospheric water? So that could be social, economic, and geopolitical surprises. How do we anticipate technological surprises that are going to be disruptive or transformative, maybe seemingly impossible in the present, and that could really change what we deem as plausible regarding our modification of the atmospheric water cycle? And then lastly, how do we anticipate changes in power dynamics, social, geopolitical, cultural, that could really lead to new configurations of who is able to exert control and consume atmospheric water flows? That's what this is about. It's to be able to start exploring those sorts of questions. So what are some of the questions to use the futures cone? For the status quo, how has current atmospheric water cycling departed from historic conditions? We're already doing that, right? Like that's some of the science that's happening now. So we can ask that question, we can answer that in the present. What are the theoretical limits of land-based weather modification? I don't know if we have an answer to that question yet. What types of financial instruments could emerge to manage the flow of atmospheric water? What are the smallest possible scales of weather modification? What's the largest payload that a drone could carry for weather modification? What are the technological limits of drone technology and atmospheric water cycle modification? And how are other diffuse economic goods valued, such as air quality, or more broadly through cultural ecosystem services? That's in that preferable domain. So these are, for the most part, entirely new questions, maybe aside from the middle one. And this is just a sample from one scenario that we generated these questions. So each of these scenarios can generate entire new threads of research. So again, this is what I talked about today. There's a lot more I could cover, but I think I'm over time already, so I apologize. And please reach out with questions if you want to connect on this. Like I said, the paper was just published this morning, so I'm happy to send you a link if you want to read it. And thanks for your time.
Thanks a lot, Pat.
Totally different. I know, it was
Yeah,
totally
well,
different.
totally different. But I think it will be interesting for all of us to read the final questions, right? So maybe this opens up new ideas for moisture recycling or
Yeah.
atmospheric water research. So are there any more questions for Pat? Yeah, so I see one question in the chat. Well, the
Yeah,
question in the chat
that's
is
a good
just
idea.
to share the link for the paper.
No, that's a great idea. I can do that.
That's a good way to start.
Yeah, and I will say that the artwork is not in the published paper. Um,
Mm.
that was also just, it didn't seem like it fit in the paper. But anyway, yeah. So that's the link to the paper, hot off the press.
So Yanwei has a question. Simon as well. First, Yanwei.
Okay.
Yeah, thank you. It's a great talk and it's totally different way of thinking and it's inspired us a lot for the water cycle community. Yes, I like this transpiration treat is also a lot. And my question is, this is a storyline based approach, right?
Sort of. Do you mean storyline in the way that like Ted
Or
Shepard uses
story?
that?
Yeah, I mean, if you have this story line or you need stories, this means it's still based on some materials, right?
So in this case, no. So this is so there is like a storyline based approach where you might use like an individual ensemble member or something like
Yeah,
that or like an extreme ensemble member or something like that. And then using
yeah,
that physical continuity, you would then layer on some sort of story that accompanies the ensemble member.
yeah.
So this is not that. This
Mhm.
is completely separate from using, say, a simulated physical reality. So in that case, we sort of skip over that part and we jump straight where we don't jump straight. We deliberately are trying to situate this maybe around 2060, 2070, maybe further out in the future. And we're deliberately trying to explore futures that have not been simulated, that maybe are they represent such contradictory combinations of things. So maybe really high emissions with something else that's contradictory with that. And so many of the futures that we explore in these, I'm not quite sure what even combination of models we could use
Mhm.
to represent them quantitatively. Although it's a really kind of interesting um, thought experiment to think about, like, what are the combinations of models you would need to represent that.
Yes, and also for this scenario you generated, how you would like to combine with the current this policy or scenario generation this community, like the SSP or for this, they also have this
Yeah,
their community. So how what you generated can be transferred to that one. So they are like the different way of thinking, right?
totally different. Yes.
So how we can bridge these two community and to transfer to that community, and then can for us like the impact modeler,
Yeah,
we
that's a
can
great
consider
question.
this.
Yeah, and I feel like we should talk offline a little too, because I think my answer would take a lot longer than what we have time for. I
Yeah.
think the short answer version, though, is that the SSP community is really focused on developing scenarios that are able to be simulated in, say, integrated assessment models,
Mhm.
because they need to represent regionally specific emissions trajectories with the kind of the associated emissions, land emissions, et cetera. And so that's really the SSPs are really part of that kind of lineage of thinking about modeling. And so for a lot of good reasons, they're not focused on surprises. They're not focused on strange or radical futures. They deliberately don't want their futures to be ridiculous. They probably wouldn't like that part. And so I'm not sure, they sort of are looking at totally different kinds of things. The SSP has to feed into this kind of integrated assessment modeling constrained world. And this is trying to look at almost like all of the parts that the IAM community can't look at. I'm not sure if that makes sense. And I don't have an answer for how to bridge the two, but I probably should. So I'm going to think about that.
Yeah. Thank you. Yeah. It's
Thank you
great
for the
talk.
questions.
Yeah.
Simon?
Yeah, let's go.
Yeah. I got a question somewhat in that space and also related to your previous research, where you see the governance relevance of
Yeah.
this and moisture recycling and how we can kind of create or work on things and make them relevant to be picked up by a future governance or somewhat in that area. Yeah.
That's a great question. And I think honestly, one of the goals of this work would be to try and provide a new way of asking questions, honestly, and to provide a new set of questions that we can ask about all of these different dimensions about modification as well as governance, regulation, enforcement, monitoring, evaluation, simulation, like all of these things that would be required for actual governance. I think this project has helped to illustrate that there are entire universes of questions that we're not paying attention to or asking. And so I think at a first order, what this kind of work can do is to help to expand the set of questions that we're considering, especially in the context of governance, and then to hopefully set in motion new research activities that can help to fill in those gaps. Because I think this has helped, at least for me, to illustrate that there are a lot of gaps in what we think we understand about the world and how we're changing it. And I mean, to be totally honest, the governance world is nowhere close to prepared to handle this sort of, especially the transboundary dimensions of this question. Domestically, it's a different story. There's all sorts of domestic efforts going on in different countries of different rules, particularly about weather modification and cloud seeding. But in terms of the transboundary component, the world's not ready for that yet, even though we're changing things. But we should talk some more later, Simon.
Yeah, that would be great, actually. Yeah.
Thanks, Pat, for sharing this very interesting work. It's incredible how the time flies. So I would say, well, I would like to ask Ima or Chris, I don't know, not sure who of you will say something about the moisture tracking and the comparison project.